you watch in 144 Full HD only, you can see what I write. Okay, now let's see rules 2. Rules 2 is continue from rule number 1. Okay, now it says that if the network address within a closed network is preferred to be unique. Oh, okay. Okay, let's continue. Too much error, I cannot think, I cannot teach you properly. YouTuber life is so hard. Never mind. We continue first. Let us finish the lecture. And then when I upload the video, I upload the other class. The other class is very smooth. Okay. Now yeah, let's look at rules number 2. Okay, the rule says that the network ID within closed network must be unique. So first thing, what is closed network? Okay, I take this as example. Look at this green color network here. This green color network. Okay, let's say this is my network. Okay, now when we say closed network, it means the network that is very near to me. Technically, it means the network that is connected with the same router. Okay, the network connected to the same router is called the closed network, or some people also call this adjacent network. Okay, or people also call this directly connected network. Okay, now why is this thing important? Because rules 2 say if you are my neighbor, let's say you are just beside me, we cannot have the same network address. Now this might be a bit confusing to you right now because we haven't actually talked about how I know what is the network address. Okay, so to make this easy, let's look at this example here. Let's say this network, green color one, I have 2 closed networks. So I will use yellow color now to show you what is the closed network. This green network is connected to this router. In the same router, there is another network here, this yellow color one. So this yellow network is a closed network to the green network. Okay, now look at the next router here. This router, green color is also connected to this router, and then this router also got another network connected to it. So the second yellow color is also directly connected. Now here we can say that this green network is directly connected to 2 closed networks, which is the one you see in yellow color right now. Okay, these are closed network. So what does it mean is that if we are close, okay, just like you and your best friend, you cannot, if you want to get a boyfriend, you cannot get a boyfriend who is your friend's boyfriend. That is not good. Okay, so you cannot reuse the same IP address. For example here, let's say I use 192.168.1.1 for this PC. Now this PC here, I cannot use 192.168.1.1. This is not correct because we are closed network. I cannot have the same network ID, so we cannot use the same IP address. Okay, so you see, right now, when we first learn about IP, we know that there are private and public. And we also know private IP is reusable, means that anyone can use the same private IP over and over again. Okay, but if we are in the closed network, I cannot use the same private IP. This is the second rule. Okay, so what it means is I can use any IP from other network, like I can use 192.168.1.2.1. that is okay, as long as I don't want to reuse the same IP. Now the same IP here, if I talk about this PC, let me ask you a question. Can I use 192.168.1.1? Is this correct? Is this correct? Actually, yes, this is correct. Now the rules doesn't change. This private IP can always be reused by anyone in the internet or anyone in this world. But you cannot if we are close to each other, if we are just next to each other. So you see here, this network here, okay, compared to green color network. So we have a green color network, and then we have another network. I use purple color right now. Now these two network is not closed network because you see they are not connected to the same router. In fact, they are connected to two different routers. Okay, so because we are not close, I can reuse the IP address, no problem. I can use the same IP like what you use here. So this is rules number 2. Okay, so let's wrap this up. We can always reuse private IP if we are not close to each other, which means I'm not just next to you. Okay, so I hope you can get this concept here. And then we go to rules number 3. This error is making me headache. I cannot focus on the class. Okay, now rules number 3. Let's talk about subnet mask. Okay, subnet mask, we already seen subnet mask in the previous lecture. That 255.255.255.0, that is a subnet mask. So in this class, we want to be sure about why we even use a subnet mask. Okay, so I want you to think of the internet as a very large collection of address space. Let's say this is the internet. Okay, this. If you look at this internet here, we are, let's say IPv4. So the whole internet, let's say this one, this green color represents the whole address space that we can use in this world. Okay, and you know in this world we got like how many billions people, how many devices that are connected. So everyone will have to share all the available address here. Now all this address is controlled by, again, the elder called IANA. Okay, the IANA that I said earlier, the elder of the internet. So they are the guys who say who can use what IP address. So for example, in our case, let's say I'm a Maxis subscriber. When I pay some money to Maxis, they will give me a global IP address. And with that, I can go to the internet. I can do whatever I want on the internet. Now, before Maxis can assign an IP address to me, first thing is they also need to buy IP address from IANA. Okay, so let's say this is hotlink. Okay, I use red color, hotlink. Okay, so they want to buy IP before they can sell to you. So they go to IANA, they say, okay, I want to buy 1000 IP address. Then I pay money, it becomes like that. So now this address space is already allocated, the red color one. No one else in the internet can use this space here. It belongs to Maxis from here onwards. Okay, and then all the green color means still available. If you have money, you can buy. Okay, then of course DG also want to buy. So DG, yellow color one, he pays some money, then I get some address space. So you see something like this. So you see now, this is how it works. This big piece of cake, we have to chop to smaller pieces so that different ISP or different telco, they can have a piece of IP address that they can sell to their customer. Again, same thing here. After this one buy, maybe Cellcom, blue color also want to buy IP. So this tree is already is reserved for Maxis, DG, Cellcom. The green color one is still open, you can buy. Now, how does IANA slice the cake? Like, how do they make this into 3 different regions for 3 different ISP? How? They use subnet mask. Okay, which is why today we want to learn about subnet mask. Okay, now before that I have a question. 2 closed network is preferred to be unique to prevent IP conflict. Yeah, you can think of that. Jiashen, that is correct. That is correct. Okay, next. This is subnet mask. Next thing you want to know is when we talk about subnet mask, there are 2 kinds of subnet masks. Okay, the first one is a fixed, the second one is called a variable mask. So let's look at this. Okay, so we have already talked about this earlier, so I just want to show you this again, and then I want you to know, to be very sure about what is the scope. Now, a fixed mask means that this mask cannot change. It's always /8, /16, or /24. Okay. Meanwhile, a variable mask means that it can be any number, and this number can start from 5 to 30. So it can be like this: a /5 mask, /6, /17, /19. This all is correct, and we call this a variable length mask. Okay. Now in datacom, we only learn this fixed length mask. Now let's say if you get a question that is a variable length mask in datacom, don't worry, I will show you a trick how to use a calculator later, and then with the calculator you can easily count for all the network that is actually even using a variable length mask. That's very straightforward, but that is for later. So we will focus on these three first, and then based on this one, later on we can calculate a lot more things once we understand more about subnet mask. So let's talk about this subnet mask example. Just now we say that with a mask, the elder of the internet can cut the IP address, the big piece of cake, to a smaller user. So Maxis can get a bit, Cellcom can get a little bit, DG can get a little bit. So when we cut the IP address, it means something like this. So let's say I have an IP address 192.168.1.1. Now, if I have a /8 mask, it means that I'm cutting the IP address at this place, /8. Okay, why is it like that? It's because remember that IP address is 4 octet. 4 octet means that the first octet here, okay, I will just draw the line to show you we have 4 octet here. Okay, now it's a /8. Until here is /8 because the first octet is 8 bits. So this is a /8, correct? Now, after this, the second octet is a /16. The third octet is a /24, and of course the last one is /32 the last one. Okay. Now this is fixed, so if you think this is hard, you can just remember this as is. Because we have 4 octets, so it's /8. Second one is /16. Third one is /24. And then you finish the whole IP is /32 because IP address is 32 bits. Alright, now, so when I have a /8 mask, what I mean is I actually try to cut the address space here at the /8 position. Okay, now if I have a /16 mask, so if I have a /16 mask, what I mean is I want to cut the address space at the 16 position here. So this is how I will cut the address space here. Okay, now if I have a /24 mask, that means I want to cut the address at the 24 position here. So I will cut here. Now, this is what we mean by having different subnet masks. So you can see every time we have a different mask, whether a /8, 16 or 24, you will have different IP addressing design. So what do I mean by that? Let's go back to a /8 example. Okay, now let's do a /8. So again, the same IP 192.168.1.1. Okay, now if this is a /8 mask, based on what we learned earlier, I will actually cut the address space here. Okay, so why do we cut? The reason is because we want to, depending on what kind of network you want to build, you can have a bigger network but smaller number of network, or a lot of network but the network will be very, very small. So if you look at this, when we cut an address space, what it means is we are actually separating this IP address to two parts. The first part is called the network ID, and the second part is called the host ID. Now, with subnet mask, every IP address now there are two portions. Okay, the leftmost portion is called the the network ID, and the remaining is called the host ID. Now, in this /8, you can see that you have only very small net ID. So you see this one is like 8 bits. Okay, and then here is 24 bits. So what it means is that if I have a /8 mask, when I want to build the internet as we have today, I cannot have too many network, because this network ID means the address you use to build network. Every network, every company will have their own ID. Maxis will have their own ID. Digi will have their own ID here. Apple, Google, Amazon, all of them will have one ID here. This one is to build company network. Okay, and then in each company, of course, you have many devices. Like in Utah, we have so many labs, and in each of the lab, they have so many PC. All the PC also need IP address. Those IP address will come from this part, the host ID. Okay, so you can think of this like this. The network ID is for the company, like Utah, Digi, Cellcom, Amazon, Google. And within the company, the device who is trying to get an IP will have an IP from here, this host ID. Okay, now in a /8 design, you can see that you cannot have too many companies, because this you only have 8 bits of number that you can play with. But the company that you build, inside you can have so many IP, because you have 24 bits of numbers here that you can play with. So a lot of IP. Okay, now let's look at another example first. I will now show you how it looks like if this is a /16. Okay, so now a /16 mask means that we are going to cut at the right in the middle here. We cut right in the middle. And then you will see that in the leftmost part, this is the net ID. Here, this is the host ID. Now in this design here, you have 16 bits for network, 16 bits for host. Now it's balanced, equal. Alright, so what it means is now with this design, you can actually build more company, because now you have more address space here. So you can have more smaller company. But the downside is that when you build a network like this, the host ID is actually lesser than what we see earlier in the /8 example, which means that the company cannot have too many PC. Okay, because now you have less number of IP that you can use to provide to the PC in your network. Okay, that is the reason here. Now, the third example is a /24. So if we have a /24, this is how I will cut it. I will now cut at the last octet here, because it's a /24. Now in this design, you can see that the front part here, the net ID, and the last part here is the host ID. Now this design is like so extreme. You have so many bits for the network part, but you only have 8 bits for the host part. So what it means is, with this, you can build so many companies in this world, because you have so many IP, the network ID that you can give to the company. But the company that get this allocation, the network is very small, because you only have 8 bits. So in fact, you only have 2 to the power of 8 IP addresses that you can give to the PC or your employee in your company. So it's actually very small. Okay, so but anyway, what I want you to see here is that we have 3 fixed masks, 8, 16, and 24, and this is how they are different when we use different masks. Okay, now to show you more, to visualize this a little bit clearer, now I will play you a video without sound. Okay, without sound, and then I'll explain. Okay, now look at this example here. This is the IP address. For every IP address, you have two parts, network bits and host bits, or it's also called net ID or host ID, the same thing. Now, if I want to build a network, I want the internet to have a lot of network, okay? What I have to do is I want to cut at the end of the right side. I want to move the slider to the right so that you see, if I do something like this, look at the circle at the bottom, okay? The circle at the bottom represents network. You can think of them as network. So you see, as I slide to the right, it means that I can start to build more and more networks. More and more networks start to appear. Yes, but you also notice something. The network is very small. The circle is very small. Means that I cannot have too many people in my network. I don't have enough IP for you. Okay, now then how about company like Google and Apple? I'm sure they have millions, 100,000 of employees, right? So a small network is not going to be enough for them. Utah maybe can, but Google cannot. So they need a bigger network. So when you need a bigger network, you want to slide the mask to the left side, towards the left like this. See, if I slide this to the left, okay, wait. Okay, see, now you see, some of the circles start to disappear. Means I cannot have so many network anymore, but the circle become bigger. Means that now the network that you build is actually bigger in size, which also means you can put more employee in the network right now because you have more IP addresses. All right, so this is the intuition here. Give and take, because we only have this many number of IP. I cannot have win-win situation. So if you want to have many network, the network will be small like this. If you want to have a bigger network, then you cannot have so many number of networks in this world. Then your network will be bigger. And the way we control this is by using the subnet mask. Okay. So far okay. So far okay. Are you watching me in full HD? Okay, now if you're okay with this, then let's go back to the slides here. Hey, watch in full HD better. Okay, now subnet mask is a 32-bit, is used to determine the boundary. So we already explained this one here. The interface. Okay, we can skip this one and then we go to principle number 4. Okay, now this is what I just explained to you. Principle number 4 says that this is so weird. Okay, Kesa1, like I say, in this data comp, we don't learn about variable length mask. Okay, variable length mask only for IPP level 2. 1 minute behind is okay. Now, the function of subnet mask, okay, this is what we just learned, is to divide IP address to network ID and then to host ID. So this is the reason we even need a subnet mask. Like, if this is not the reason, why would we need a mask? Why you want to make life hard for yourself? But we need this because the reason I explained earlier. With a mask, you can cut the IP space to different people depending on how many IP they need. Okay, now this is principle number 4. Every IP address have two parts, network ID and host ID, depending on how you cut and what is the mask that you use. Now you can skip all the example here. Later on, I'll give you some better examples. All right. Okay, so let's talk about principle number 5. By right, you're supposed to have a break now, but we already break for 10 minutes due to the technical problem, so now no more break for this class. Okay, now let's look at number 5. It says that the IP address of all hosts and gateway must have the same network ID. Okay, so what number 5 tells us is that if we are in the same LAN, okay, then we must have the same router IP and the same network ID. So this is what it means. Let's say this is a router, okay? We know that every time you have a router, you will have a new network. So if I do something like this, I connect both sides of this router to a switch. I know that here, this is one network. On the right, there is another network. Okay, now principle number 5 says that if you are in the same network, so if I am PC0 and you are PC1, then we need to have the same network ID. We also need to have the same gateway, which just simply means that we have to have the IP address that is coming from the same network. So how do you know, okay, what is the IP address that I should use in my network? Later on, I'll show you 3 examples, and then from there you will know. But as of now, I just need you to think, just remember this. If we are in the same LAN, then we need to have the IP that is from the same network. So for example, if I have 1.1, okay, then the network ID, I will tell you how to calculate later. Now I will just give you the network ID directly. This is the network ID. Okay. Then PC0 also must have a similar IP from this network, and we both have to have the same router IP. So let's say this is 1.254, then everyone will have this same router IP. So this is just a quick example. This is not really important yet. Okay. Now you will get this clearer if you see how I calculate later. But before that, let me give you one example. One more example. This one is a more difficult example. Now look at this diagram here. Okay, in this simple diagram, now we have 4 PC. Okay, PC 0, 1, 2, and 3. Now I have a questions for you. Let's say if I am PC 2, okay, and then I want to know whether I can communicate with my friend. And the way we know is using the ping command. So let's say I am PC 2. I want to know whether I can talk to PC0 or not. So I want to know whether can I ping. Alright. So in this case, rules number 4 says that you can ping your friend if you are in the same network. If you are in another network, no, you cannot ping. Alright. So this is rules number 4. Based on rules number 4, we can answer this question easily. Can you ping a PC? So now, do you think PC2 can ping to PC0? We just have to see whether they are in the same network. Okay, so over here, you want to get all the network ID for all of them. So it's not okay. Before I show you how I solve this question, I want you to be very clear. You cannot just say, okay, by looking at them, looks like they can or looks like they cannot. No. You cannot guess like that. It has to be scientific. Okay. So over here, you want to get the network ID first. 10.0. Okay. I will now write the network ID for you. 10.0.1.0, 10.0.1.0. So this is the network ID for PC2 and PC3. Now for PC0 is 192.168.1.0, 192.168.1.0. So this one is the network ID for the PC at the bottom. Yeah, your friend is correct. Actually, it's no. Very smart. I don't think they have delay. So you see, in this case, PC2 and 0, let's look at their network. This 10, this is 192. They are not in the same network. So the answer is they cannot ping because they are not in the same network. Now, another example, PC2 go to PC3. Do you think they can ping or not? The trick is just to see whether they are in the same network. So let's see. 1, 0.0.1.0, 10.0.1.0. This is the same. So yes, this one can ping. So this is rules number 4. If you are in the same LAN, you can ping. Okay, now the trick is that you cannot just say, okay, they are all connected to the same switch, so they are in the same LAN. Okay, if data comp is so easy, something is wrong. So you want to be able to calculate first, like, okay, this, they are in the same network, and then here, they're actually in another network. Although they're physically connected together, but in fact, they are in 2 different networks. Okay, so this is rules number 4. Correct, correct. Cheese and pizza, thank you for your answer. Now we go to rules, now this is rules number 5, sorry, I miscount. So now let's go to rules number 6. Rules number 6 is very easy because we talked about this for so many times. If you want to send a data to a destination which is not in the same LAN, you need a router, because a router is the network device that will help you to forward your packet outside your own network. So the data has to be sent to the gateway. Okay, it's not the same network ID. So this one, I mean, they write in this kind of English, it simply means that if you send a data to someone who is not in the same LAN, you send it to a router. So let's look at this example here. So in this example, I'm PC0. Okay. Now, if I take PC0, I try to ping to PC1. PC1. Okay. In this case, continue from principle number 4. We know that yes, this can ping because they are in the same network. Then they can ping. No need router. But if I want to ping to 2.1, then we look at this diagram here. Where is 2.1? Where is 2.1? Cannot find. Means that this 2.1 is somewhere here on the internet. Okay. Now, if you want to send a data from PC0 to to this PC with 2.1, you need to send it to a router. Same example, if I send to 180.7.4.3, so it's also somewhere here. This guy is somewhere here. Okay. This guy is also somewhere here on the internet. We do not know exactly where they are, but we know they are somewhere on the internet because it's not within my LAN. Now, for all these 3 ping, you need to send it to the router. So this rule simply says that to go to the internet, send to router. I can explain this in 6 words. Why they explain it in so long? Okay. Now, before we go to the next one more thing. I want you to be very clear about how this thing works. Okay. Okay. Pay careful attention here. And I want you to focus exactly on how the packets travel when in different scenario. So the first scenario is like this: PC0 ping PC1. Now, in this case, no need router, okay, because they are in the same network. When you send a data from yourself to a guy who is in the same LAN, the data will go to the switch directly and it will not go to the router. Okay, so this is how it goes. The data will go here, and then it goes to the switch, and then from the switch it goes to PC1 directly. So this is how it looks like. Here it goes to the switch, and then it goes to PC1 directly. It will not ever go to the router. Same thing for PC2. If I send a data to PC2 from PC0, it will go to the switch. Alright, it will go in this way to the switch, and then it will go straight to PC2. It will never go to your router. So your router is actually like, oh, my job is so easy, I got nothing to do. Okay. Now, if you go to anyone that is outside the internet, so let's say you go to PC3, and let's say PC3 is somewhere on the internet. Now, in this case, the data will go to your switch, and from your switch, it will go to your router, and then it go to PC3. Okay, so I want you to be very clear about this. If you send to someone who is just next to you in the same LAN, send to the switch directly. The switch is the guy who will make sure the destination get the packet. If you go to someone outside your LAN, then you need a router. Okay? So switch can connect to two different ID means there are two different LAN. Yeah, that is correct. I think this one is going back to the example earlier. We have a delay comment from the chat. Okay? So yeah, if you guys is asking like, okay, does that mean I got two network here? Correct. Yes, this is two network, LAN 1 and LAN 2. Which is why I say you cannot just say, okay, my eye tell me that is in the same LAN, or my heart tell me that it's the same LAN. No. In datacom, you have to use your head. Okay. Okay, now let me just show you one more example. I think still cannot, man. Some people can, some people cannot. I also don't know why. Okay, now the next principle here, principle 7. Router must be used for two hosts to communicate, in different network to communicate. Now this one is very important. Okay, this is very important. Okay, now if you have this example here, so this is the example that we have earlier. This is from example number 4. You know that now we have two network here. Okay, one in green color and then one in yellow color. Now you know that this guy here cannot talk to each other, but this guy here can. This is what we have so far. Alright, now of course we cannot say that, okay, you cannot talk, that's it. No, the whole point of internet is to connect everyone together so that you can find your girlfriend among a billion of people. Once you're connected, then you get the chance. Okay, now this one here is a switch. If you want two different networks to talk, means that you want this one to be able to talk, then you need to use a router. This one here, change to router. This is how you fix the problem. If you change the switch to a router, then automatically router will be able to forward the packet from one LAN to the other LAN. So this is how it looks like. You see, this is PC. Earlier we have again two network here. So the trick is that you want to connect them to a router, and then with this design, now they can talk to each other. This guy can talk to each other. So for example, let's say PC0 try to talk to PC2. Now this time the packet will go to the switch. Again, you are not in the same LAN, so I send to the router. When the data arrive at the router is smart enough to know how to get to this network and then get here. That is why router is so expensive. Okay, so principle number 7 says that if you want two different networks to talk, use a router to connect them. That is principle number 7. Okay. Now, principle number 8 is called host ID. Now, this one is the most important principle among all the principles. So let's read this one slowly. Okay, there are two special cases of IP address. First one is called a network address. Second one is called a broadcast address. Okay, I will just take some question from the chat first. Otherwise, it will be out of sync. So if PC1 and PC0 connect to router directly, the ping message will be sent to PC0 to router to PC1. Yes, that is correct. Windy, that is correct. So Windy is asking on the chat, if we connect the PC directly to a router instead of connect them to a switch, the packet will be sent to the router. Yes, that is correct. The reason I do this is because we all know router is too expensive. So I cannot just connect one PC directly to a router. Then I need to buy so good router with more and more ports. So it's just too expensive, which is why we always connect to a switch first. Alright? Okay. This class is so tiring because the YouTube make me tired. Okay, now let's look at principle number 8. So we have two special case of address. The first one is called a network address, which is what we already hear so many times before. And the second type is called a broadcast address. Now in every network, you have a network address, you have a broadcast address. So network address is the very first address in a LAN, and that address is used to represent the whole network. So let's say you have a network like this. Okay, so let's say this is our network here. You have a PC1 here, you have your iPad here. Okay, this you have your iMac here. They are all connected to a switch, to a router, and then to the internet. Okay, now this is my local area network. It doesn't matter how many devices I have or how rich am I, how many devices, how many PC I can buy, and it doesn't matter how many private IP I have, because you know, like, okay, every device will need to have their private IP. So let's say this is so let's say this is .1, .2, .3. Now it doesn't matter how many. To the outside world, to the internet, they only see you as one LAN. They only see you as one unit. So actually from the outside, you cannot see what is inside of other people's network. Like from my case, I cannot know how many devices you have in your home Wi-Fi right now. What I can see is only your home Wi-Fi as one thing. So all these devices in the local area network to the outside world, they are only represented by one address, and that address is called a network address. Okay, which means that let's say this is the network address for this example, 168.1.0. Let's say this is the network address. Now anyone from the outside try to send a data to the iMac right now. So I want to send something to the iMac. Okay, what they see is this address. The data will be sent to this address. I do not know what is the iMac IP one. Okay, so outsider do not see the inside of the internal LAN. They only see them as a whole thing. So let's say another guy try to send some data to iPad. Okay, come here. They also don't know what is this IP. They will just send it to this network address. So that is network address. It is used to represent everyone within a same LAN. Okay, which means that this address is actually very important because it represents all of us. Like in Utah, let's say one day all of you come back here, we have like thousands of students here, but anyone on the outside want to send some data into our Utah network, they only see one IP. They don't know we have 100 students here. Okay, so this network address is not used to assign to any host. You cannot take this number, this IP, and you give it to one PC. Because if you do so, it's very selfish. Then the whole network becomes just one PC. Okay, you always want to keep this number to represent the whole network, not one guy. Okay, now the next address is a broadcast. Broadcast means like a PA system. I want to announce this Saturday we have quiz. Please make sure you wake up on time. Something like that. I want the whole class to know about the announcement. So broadcast is an address that you use if you want to send the same data to everyone in the same LAN. Okay, so again, let's say if I have I'm in a lab, I got 20 students in my lab. I want to send the web document for you or lab manual to everyone here. I will send it to a broadcast address. Then everyone can get the same data. Alright. Now in every network you have this broadcast address. In a while you'll see how we get this number. Got error again Got error I also don't know why is YouTube doing this. I already pay YouTube Premium. They still do this. Okay, now next part here, I want to show you some technical example on how we get these two numbers. Okay, so over here I will have 3 examples for you. Now there are 2 ways you can do this. Either you write this on a piece of paper, or you can also use an iPad if you have an iPad with you. If you don't have an iPad, you show this video to your mother. You tell her that you need an iPad to continue study. Okay, now now these 3 examples, I will show you how you calculate for network address, broadcast address, and everything in between. Okay, but I just want to make this clear. right now, what you learn is, okay, it's going to feel really cool. Like by the end of this class, you can tell people, or you can even post on your Instagram story, hey, I know how to calculate network addressing. But the smart guy will say, hey, it's nothing, because all the thing that we are going to learn later, you can do that with a calculator. So that means you calculate manually, it might take you 5 minutes. If you use calculator, it only take you like 5 seconds. You get the same thing. But still, I want to show this to you because I want you to understand the concept behind all these things. Okay? It's not because I don't have anything to show, but I want you to understand the concept. Okay? After you do this, after you understand this, let's say in the exam, you have a questions like this. I want you to use calculator. Do not calculate manually. Okay? Calculate manually only make you feel good. You feel good, but actually you are not that good. So you want to use calculator. Okay, now, example number 1. I don't want to look at the chat anymore. It make me cannot focus. Now, 3 example. What we want to do is we want to calculate what is the network ID and the host and the broadcast ID. So every time for this kind of questions, you will get 2 things. You will have one IP address and then one subnet mask. So 2 things. Without either one, you cannot actually calculate. So first step, you want to convert them to binary. So all the things you see here start with decimal number, and you want to convert to binary. So first thing, how you convert to binary? Use a calculator. Now I need you to open your calculator from Windows 10 or Windows 11. Okay, so you see right now, don't do this manually. Okay, use a calculator. Go to your search bar, type calculator. This will open your Windows calculator. Now this thing here is the best thing you can have in Windows. I think this is the only reason I still use Windows, because the calculator is so good. Okay, now this is the calculator. This is what you want. Okay, when you first get in, I think the first time, if this is the first time you're using it, you will see this default view is standard. You want to go into programmer mode. So on this button here, click on programmer. Okay, this programmer. Then it will give you, you can do the binary hex conversion with this. Okay, now, based on our example here, I will go to click decimal. Make sure you highlight this one here so that you're in the decimal mode. And then you type 192. From here, you can see this is the binary for 192. It's 11000000. Okay, so you go back to the example earlier. 11000000 dot. Okay, next I want to convert 168 to binary. So I go back to the calculator now. Click on decimal again. Press the CE button to clear, and then you press 168, and this is the binary. So quick, like few seconds you get it. Don't even have to count. So 1010 1000. Go back to your example. This one is 1010 1000 dot. Okay, now I want to convert this one dot 1 in decimal to binary. You know, dot 1 don't press that. Dot 1 everybody know is 00000001 dot. Okay, now if you press calculator for dot 1, it means you are insecure. Like me, even in my math test, 1 plus 1 is 2. I know it's correct, but I still press calculator just to be sure. Okay, now then the last octet here is 00000001. So this one here is the IP address in decimal. You convert them into the binary value. Okay, now you have to do the same for the subnet mask here. So it's 255.255.255.0. Okay, now I go back to my calculator now. I clear screen, go to decimal. What is 255 in binary? Look at here, it's all 1, all 1. So 8 ones. In fact, next time you don't even have to press calculator because 255 is always 81. Okay, so it's 1 1 1 1 1 1 1 1. Dot. Next, here is the same, another 255, so another 81 here. Then another 255. Okay, another 81 here. Dot. Okay, this one is 0. 0 decimal means 80 in binary. So this is your subnet mask in the decimal, in the binary format. Okay, so once you have these two things, it's very clear cut from here onwards. Press. You just need to do an AND operations. So we are actually doing a bitwise AND. I won't be repeating this one because you learn this in your ICOA. So just to make sure you know this, in bitwise AND, if you have two ones, you will get 1. Other than that, it's all 0. So if you have 0 0 0 AND with 0, you get a 0. You have 0 AND with 1, you will get a 0 as well. Okay, 1 AND with 0, you get a 0. But if you have 1 AND with 1, this is when you will get a 1. So this is a bitwise AND. Now with these two things, we will now do a bitwise AND starting from the leftmost bit until all the way we finish for all the 32 bits. Okay, so I will start with the first bit here, 1 and 1. So I get a 1. Okay, 1 and 1 again, I get a 1. 0 and 1, I get a 0. 0 and 1, I get a 0. Now I'll continue to do this in this way. Now I don't want to do that bit by bit, later you snooze off. So now I'll just complete the rest for you. But I think you get the idea on how I do the bitwise, right? So it's 1 0. In fact, you will also notice that you are just rewriting the same number here because it's all 1. So actually you get back the same value. Okay, this is 1 here because it's 1 and 1, so this is 1. Okay, and the last octet here is all 0. Now the last bit 1 and 0, so this is a 0. Now this is your network ID. You already get your network ID. So simple, so easy. Okay, now for the broadcast ID, okay, this is a network ID. Broadcast ID means that all the host bit to 1. Okay, I think that's a bit difficult. Let me just show you this example first. So once you have this answer, you don't want to leave it in binary, of course, otherwise like this is a bit alien language. You want to convert them back to decimal. Okay, so to do the conversion back is also using the same calculator, but this time you make sure you highlight on binary. Okay, click here to highlight on binary, and then you type in this number 11000000. So it's 11000000. Then here, this is 192 in decimal. And with this one here, now you can go back and write 192 dot. Okay, and then you do the same for the next octet, you will get 1.0. So this is your net ID in decimal. And this is the final answer that you want. Okay? Okay, so this is your network address. Now we can do the same example for the next one, but now I'll go a little bit quicker for you. Okay, and then we have a 3 example here for this principle. Okay, cool. iPad no calculator. Yes. I also don't know why iPhone got calculator, but iPad no calculator. Okay, now we are in example 2. I will do the same. And again, what we want here is, can I know what is the network ID for my network? So same thing. If I have one IP and one mask, yes, I can. Okay, so now I will just do this example again. But this time, I don't want to convert. I want to show you a new trick. Now, when you see a 255 in decimal, it means 8 ones in binary. Even if you do an AND operations, you will get back the same value. So the shortcut here is that when you have a 255 here, you can just rewrite the IP here 192. Don't have to calculate, or you don't even have to press any calculator. Okay, so again, a 255 here, you just press 168. It's 168, no need to press. Okay, now when you have a 0 here, it's always 0. So when the mask is 0, whatever that you count will always get a 0 because it's a bitwise AND. Okay, the last one here is also if you have a 0 mask, then this is a 0. And this is your network ID. Okay, so this is a faster trick for you. If you have 255, you can just directly copy the IP address here without needing to do any conversions. Okay, if you have 0, it's always 0. So this is the network ID for example number 2. Okay, now we go to example number 3. Example number 3 is a bit different because you see, now this time here, the mask is a /240. Now, if you have a questions like this, definitely you have to convert because there is no shortcut. Shortcut only work for 255, 255, 255. Okay, now there are two kind of people here. If you want to be like, okay, step by step, you do all the way, then you can do all these binary conversions, decimal to binary, and then you do AND operations. Or you can just, if you are eager eye, you already know this, you can just do this for the last octet. Because you know the first 3 octet is 255, 255, 255. So based on the second example, we know that 255 you don't even have to convert. It's always the same value. So it's 192 dot, here is definitely 168 dot, here is definitely dot 1, correct? So in fact, we only need to convert for the last octet, which is what I'm going to do now. I will convert this IP18 to the binary and this mask to binary. Okay, so calculator, go to the decimal mode, clear the screen, 18. In binary is 0001, 0010. Okay, so I go back to my notepad file here, 0001, 0010. Okay, let me 110. Okay, so that's correct. Okay, so this is 18 in binary. So now I need to convert this one to binary, 240. So go back to decimal again, 240. In binary is 11110000. So come back here and write here. It is 11110000. Okay. Now, if you have this, the next thing is you just do an AND bitwise AND operation. So we will do this bit by bit now, starting from this bit. Okay, so a 0 and a 1, you get a 0. Okay, a 0 and a 1, you get a 0. 0 and a 1, you get a 0. 1 and 1, you get a 1. And then here is 0, 0, 0, 0. So this one is the value for the last octet. Now what we want to do next is we want to convert this one back into decimal. Okay, so what is 1000 in decimal? Go back to your calculator now, clear screen, binary 10000. So in decimal is 16. So here we know that with this calculation, this is actually 16. So for your final answer, you should always write in decimal. So it's 192.168.1.16. So this is actually the network address for this example number 3. So this is your network ID. Alright, and that is how I can know what is your network ID. If you tell me one IP within the network, and also if I know your subnet mask. Okay? Very smart. Hash is our calculator. We don't even need to press calculator. You just have to say, hey hash, what is 000010 in decimal? Then hash will reply to you what is the number, just like Siri. Thank you for telling us, because some people very lazy to press calculator. Okay, for those who are lazy, the answer is already given here. So I need you to be very clear about these three examples. So what you can take away is this is how you calculate a network address for every LAN. Okay. Now, if you're okay, the next example will be even more difficult already. That is the boss fight for today. Okay, now we go to principle number 9. Okay, this one is the main cause of this lecture. Okay, we want to be able to know what is the usable address range. So you see, okay, today, yeah, I also game over. I feel so tired. I don't know why. I think it's not physically tired. Mentally here is so tired. I feel like YouTube betray me. I pay YouTube 30 ringgit every month, but he betrayed me. Okay, now let's talk about, I think it's YouTube server problem lah. But anyway, if Google also can have network problem, then we are not worried anymore. Even Google can have problem. We are not perfect. We can also make mistake. Okay, guys, come to this principle. So today we use 2 hours to learn about IP addressing. Why we want to learn this? First thing is, of course, this is the thing that make the internet tick. Without these rules, internet will collapse. Then the elder of the internet will be very angry. The second thing is, what is more relatable to us is, with these rules, we can actually know today, if I build a network, what is the IP I can use? That is what we want. Okay, so let's say one day you go and then you work for internet company like ISP, maybe Maxis Telco or Digi Telco, and then most of the work will be in building network. Now you can be assigned like, okay, Pavilion is building a new mall, Pavilion 2. They need 100 IP address, so they send you there to build the network. First, one of the question you will answer is, what is the IP I can use? Okay, now after you learn this principle, you can answer that question. Okay, so you see, what it says is, every network you have a range, but it doesn't mean you can use all the address. Remember, network address you cannot use, broadcast address you cannot use. So what are the address that you can use? Is here. First usable and last usable is given by network ID +1 and broadcast plus 9 minus 1. So the first address that you can use is called a usable IP, which is why it's called usable. It means that you can actually assign this to a host. Okay, that is given by, you take your network address, you +1. So if you have this network ID here, this is your network ID. Okay, the first IP you can use in this network is this number +1, so you will get 3.1. This is the first usable. And okay, now what is the last one? So you can use all the number 3.1, 3.2, 3.3 until the last one. So what is the last one? You take the broadcast address minus 1. So broadcast address is 255 minus 1 is 254. Okay, so this 254 here is the last IP that you can use to give to any host. Alright, now of course I will also want you to know how you calculate for all these numbers, and that is actually the last example. Now before I go to that last example, I will just talk briefly about all these things here, because the rest of the rules are not so important anymore. Okay, so I will skip ahead and I'll explain the rest of the principles, and then we come back to this one, because this is the essence. Everyone here, if you're watching today, or if you are still watching today, I'm very sorry about the technical issues here, but blame Google. Okay, now I want everyone here to be able to get principle 9 and you can actually know what is the IP that you can use. Okay, so that is later. Okay, now we talk about design guideline. Okay, this one is important. Guideline is a keyword. Like right now, if you are thinking, can I go back to the campus? Sometimes Utah say yes, sometimes Utah say no. Now that depends. If Utah say yes, but it is a rules, then the yes is a yes, cannot, can come back. Okay. Now if it is a guideline, then when I say yes, it doesn't mean yes or no. It's just a guideline, so it's up to you to interpret whether you want to come back to the campus or no. Is your choice. What I'm saying is the guidelines say no, you cannot come back. But if you insist, I will not stop you because it's not rules, it's guideline. Today what we learn here is subnet principle. Subnet principle is rules. You must obey. You cannot change it. Unless you are rich enough to buy the whole internet, you cannot change any of the thing we learned today. Okay, so rules and guideline is very, very different. Now in networking, we have a lot of guidelines. You have Cisco guideline, you have Huawei guideline, you have Apple guideline, different guideline. Okay, so this guideline you see here is a Cisco guideline. It says that it is best if when you design a network, you want to keep the first few addresses for server. So you see, first IP are preferred to be for servers and printers. And the last IP is always for the routers. Okay, now this is just a guideline. Normally we want to follow because you think about this. Today I work for Utah and then I'm the guy who set up all the server. If I don't follow guideline, I randomly take any IP for the Weber server. Then tomorrow, Google sponsor my channel, so I don't work here anymore. They will hire a next guy. The next guy come, he want to configure Weber. Hey, what is Weber IP? He do not know. So if we follow guideline, it's very easy for him to guess. It should be some IP address that could be .1 or .2, .3. So he can just make a few try and then he can get Weber IP. Alright, so this is why we need guidelines, so that the next people who take over can somehow guess the network design. Router is also the same. If you always use the last IP for your router, then every network I go, today I visit your house or your friend's house, I cannot know everything, but one thing I can know for sure, your router IP is .254. Okay, because this is a guideline. But again, it doesn't mean you have to follow. So if I say, okay, 254 is too mainstream, I want to set 1.88 as my router. Yes, it will work. It will work because it still follow the IP principle. Okay, so anyway, this is up to you. Let's say in the exam, you have some questions like that. It doesn't mean that you have to always put 254 as your router. It's totally up to you. This is just a guideline. Alright, so now principle number 10 is what I already discussed earlier. I don't need you to see this, so you don't have to see any of these things. You just want to look at class A, B, and C. So this one we have to go back a little bit. History class. We have history class in Datacom. We have cooking class in Datacom. We have many class in Datacom. Okay, so let's go back a little bit. Take the time machine and go back to the early days when we start the internet. Okay, so in the early days, of course, not many people. You are not here yet. I'm not here yet. Okay. Now the internet is actually started by US. There are a few people who built a very first network, and that is called the ARPANET. It's not the internet, it's called ARPANET. Okay, that time is like few KB only. Okay, if you want to send a picture, also it will take you hours to send just an 8-bit picture. Now in those days, not many devices. So we have a lot of IP address. And how do we decide who get what IP? Is by using this class. So it's like first class citizen, second class citizen, third class citizen. Okay, if you are first class citizen, you are in class A. Second class citizen is class B. Third class citizen is class C. Okay, now what does it mean? Like, okay, why we have different classes? Okay, it is like if you are in class A, you can build a bigger network. Okay, class C, your network is very small. Why? Okay, same concept that we learned just now. In a class A address, it uses a /8 mask. So if you remember earlier, I give you an example. Okay, a /8 mask means that we want to cut here. So the front part is for network, the second part is for all the hosts. So you see, the green color one is so big. In fact, I have 2 to the power of 24 bits. So if I have a class A address, I can build a very big network. Okay, let's say I'm being discriminated. Okay, I'm from third world. I get a class C address. So let's say I get an address like this, /24. So here you know I will cut here. Now you see, the last part only so small, but the front part is so big. And the address that I can actually use is only here, 2 to the power of 8. So the network that I can build in the end is very small only. Now, of course, this one is not being racist or what lah. It's like, it depends on what is your need. If you are a big company like Google, then you take a class A address. Okay, if you start up a small company with only 2 employees, you and your dog, then you take a class C address because you don't want to waste the address space. Am I correct? So yeah, this is why we have different classes in IP address. But then you should also remember, this address is this classful thing is no longer in practice. Okay, now we are moving to a classless IP addressing, and today, right now, the internet that we are using is actually based on a classless addressing. So we do not have class A, B, C anymore. All right. So that is called classful addressing. Now, last concept for today, and then we go back to the previous principle 9. So in datacom, we have 3 kinds of address. It's called broadcast, unicast, and multicast. Okay, I think this one you can guess by the name. Okay, we start with unicast first. Unicast means one-to-one. One sender, one receiver. One source, one destination. So look at this example here. This red color guy sent a piece of data to the green color guy, one-to-one. This is called a unicast. It's just like every night. Okay, a more relatable example based on my true example. Before I sleep, every night I have to text my girlfriend, "Good night, I'm going to bed." That is one-to-one. I send to one girlfriend only. And then immediately after I send the message, I start my Dota 2. And then I play game. But before you play game, you have to tell your girlfriend, "I'm going to bed." Okay, so that is one-to-one. You don't want to send this kind of message to so many different people. That is unicast. Multicast is one-to-many. So it's like, I want to send the same data to a few people. Okay, so this is, you see red color go to green color, so it's one-to-many. So this one is like in a WhatsApp group, you add people into different WhatsApp group. So if you send a message to a group, everyone in the group will see your message, but not all the user of WhatsApp, because we have billions of users using WhatsApp. But only your group members see what you send. That is like a multicast. Okay. Now, of course, you will have some guy who also send "I love you" as a multicast message. For me, like I send "I love you" to my girlfriend. That's unicast. Some guy send "I love you," but it's a group send to all the girls she like. That is also a multicast. Okay. I'm sure some of you are like that. I'm talking about you. Yeah, I'm talking about you. Okay, now last kind of address is called a broadcast. Now a broadcast is what I said earlier, sent to everyone, so it's one-to-all. So you see here, one-to-all. This red color guy sent to all the green color one, so it's one-to-all. So broadcast is very important. Like let's say you want a message to be sent to everyone that is within the same net. Okay. For example, most of this is used by protocols like DHCP, ARP, that you will learn eventually in some other classes. That is for another lecture. Okay, but right now you just need to know the difference is unicast is one-to-one, multicast is one-to-many, broadcast is one-to-all. Okay, so an example for broadcast, yes, time management. You see this guy here, this is the guy you should be careful. He is PhD in time management. Okay, now broadcast is like, let me give you an example. anti-WhatsApp group is broadcast. Our normal WhatsApp group is multicast because only our group people know. But if you join any anti-WhatsApp group, wow, that one I tell you, I am in one of the group because my mother added me. Before I wake up, they already send me the message, good morning, today will be a good day, wish you good luck for the rest of the day. They like to send this kind of picture to me. Okay, that is like anti-WhatsApp group broadcast. Anything that you put into anti-WhatsApp group, the whole Taman will know. Maybe the whole region will know. Because anti is the fastest internet medium. Anti-WhatsApp group is even faster than your fiber cable. What you tell them in 5 minutes, the whole Taman will know. Okay, so that is all the concept I want you to learn for this one. And then now we go back to the technical part on Principle 9. Now, for Principle 9, I will use this example. So just give me about 10 more minutes, okay? 10 more minutes and then we are done. Oh, attendance. Attendance is already on the web. Go to the web. Okay. Okay, now we'll take a look at this very simple example to tie up everything that we learned, okay? And in fact, this is a real example for Principle 9. So normally, if you have a question like this in the exam, this is how it is going to look like. And these are the common questions like everywhere you go if you take Datacom class, whether you're in Sunway or Taylor or Inti or Utah, if you take Datacom, this is one of the popular questions that you can always find in all exam paper. Okay, so these are the few things that we will learn how to calculate today. And once you know this, that's pretty much everything you need to know for IP subnet addressing. Okay, now let's look at the example here. You have a mask /24 and you have an IP. Okay, this is the only info that is given. Now we want to calculate for the rest of the items here. So first one is network address. How you calculate network address, we already learned this. Okay, so I will just do the working here for you and then you can use my answer. I have one IP. This is from here. Okay, I have a mask /24. You know that /24 is 255.255.255.0. So here you write 255.255.255.0. Okay, to get the subnet mask, we do AND operation. So here, I can use the shortcut because it's 255. I will just rewrite the value here. So now this is a 192 dot again 255. I will rewrite the value here. Okay, 168 again 255. I rewrite 1. This is 0, so this is 0. And with this, I get the network ID 192.168.1.0. Okay, now one more thing. When we write network address, you always want to write the mask together as well. So in this case, it's a /24 because my mask is /24 here. Now this is very important because if you do not write this one, then I do not know whether you are using a /8 or /16 or /24. So it is always important that you write the mask together as well. Okay, Cheese and Pizza asked this question, why we still calculate? That is because I give you the simplest example available. Sometimes it's not that simple. Okay, you get different weird number. But of course, this is the first example. I cannot give you the weird example. Alright? Okay, yeah, Tuesday QR code, don't worry. Tuesday QR code, I will add for you. Tuesday QR code is the giveaway. You just scan for today one. Okay, scan today one. Now let's go to the next question. What is the range of IP address? So now we are in questions 2 now. What is the range of IP address? Now the range is given by the first address to the last address. So you see how I solve this problem, huh? this is IP address 192.168.1.1. Okay, this is a /24. So /24 means that I cut it here. This is the /24. So here the green color one is the network part. The blue color one is the host part. Okay, let's zoom this in even more. Now, for you to get the range, the answer is two things. What is the network address and what is the broadcast address? So you need to calculate the network address first. Now, network address we all already know how, so I'll just go quick. Okay, the network address is given if you set all the host bit to 0. This is the trick here. If all host bit is 0, you get network address. Okay, if all the host bit is 1, you get the broadcast ID. So this is the rules that we want to use now. Okay, what I do is I will put 0, 0, 0, 0, 0, 0, 0, 0 here. Only one octet, so 80 for the last octet only. Now this is the network address. So it's 192.168.1.0000. Now, of course, it's always a good idea to convert them back to decimal. So this is actually a 0. Okay. Now, this is net ID. For a broadcast ID, we will do something similar. You want to change all the host bit to 1. So over here, only look at the last octet. You have 1, 1, 1, 1. 1, 1, 1, 1. Okay, and then the front part, just write this back exactly 192.168.1.1. So this one here is your broadcast address. So this is your network address. This is your broadcast address. Okay. Now, of course, again, it's always a good idea to write them in decimal. So this one is actually a 255. Alright. So now, the answer for this one is two answers. 192.168.1.0 until 192.168.1.255. So this is the answer for questions number 2. From the network address until the broadcast address, this is the whole range of IP address. Okay? Why you don't listen to the class? Why you want to worry about attendance now? Okay, up to you, up to you. Okay, now the third question is, what is the usable range? Usable range. Okay, like I said earlier, usable range means that the IP that you can actually give to a host. And you want to take this number here plus 1. So 192.168.1 plus 1 is 1. Okay, and here, this one, the last one you can use is this number minus 1. This one is this one plus 1. Okay, so the last usable IP is 168.1.254. And this is the IP that you can use to assign to any host in the network. Okay, now the next question here, what is the number of network bits? Number of network bits means that how many bits you have in the host ID part. Okay, so this is how you solve these questions. So in this example here is a /24. So we actually cut in this way. And then you have the network bit in green color, and then you have the host bit in purple color. Now we also know that every IP address is 32-bit long. So if you cut here, every octet is 8 bits. So here is 8 bits, 8 bits, 8 bits. So here you have 24 bits. And then for the host part, you have 8 bits. which means the answer here is 24. The number of network bits is 24 bits. And the same thing, the number of host bits is 8 bits. How I get this? I see the mask, I cut it, and then I see how many I have in the network portions, how many I have in the host portions. Alright? So, next one, last two. What is your router IP? Now this one is, let's say, if we follow the Cisco guideline, okay? What do you think the IP address that we should give to the router? We always want to give the last usable. So here we already get the last usable. So we will now want to take this IP address and then we assign to the router. The answer is 1.254, the last usable IP address in your LAN. Okay, now the last question, this is the most difficult one. How many usable IP, host IP, how many usable? So this question is asking you how many IP address that you have that you can give to the PC. Is it 1, 2, 3, or 10, or 100, or 1,000? So the way you get this answer is from here. You want to focus back on this thing here and look at this host part, this host ID here. You have 8 bits, okay? Which means that the number of IP that you can use to assign is 2 to the power of 8. So this 8 bit come from the 8 bits that we get from the host portions. Okay, then you need to minus 2. Because you cannot use a net ID, you cannot use the broadcast address. So there is always 2 address that you cannot use. So you need to minus 2 and then you get the answer. Okay, now you can leave the answer like this. You don't even have to press the calculator. That is okay. But if you want, you can give me a real round value lah. So this is how I get the number of usable hosts. Now let me give you one extra example before you go. If I have this IP address now, 1.1/16, okay, if I have this IP. So in this example, I will cut it in this way. And here, it will be the host part, the network part. And here it will be for the host ID. Now, if I ask you the same questions, how many bits do I have for the network? Is 2 to the 16? It's 16 bits and 16 bits. Alright? Now, the number of usable hosts in this case now is 2 to the power 16 minus 2. That is the number of usable host IP. Okay? So yeah, that's pretty much everything that I want to show you today. I hope you can get this example because this is like the prime example to tie everything together. And if you're okay, make sure you do the revision for this one because this is part of your quiz one. And thank you for joining me today. I'll see you on the next lecture next week. Okay, so you have a quiz first and also you have lab this week. I'll see you on the next one. Sorry again for the technical issues earlier. Enjoy your day. Bye bye.